Alright, for this last sample problem we're going to use our graphing skills for a little different type of problem here. What we've been given is a model of a function of a ball that's being hit in the air, and then of course is eventually going to come back down and hit the ground. And they want to know in the first part how long the ball stays in the air. So what I'm going to do is I'm going to just kind of give myself a visual of what that's going to look like to start. And I'll just basically draw the graph here. And of course it started roughly about 4 feet off the ground, went up, came back down, and hit the ground. Now keep in mind that the height is over here and the time is over here. So we're trying to figure out in part A about how long the ball was in the air. So we want to know how long it took until it came back down here and had a height of 0. That's where it hit the ground right there. So it was in the air from the time it came off the bat right here at 4 feet off the ground. It was in the air all the way until 0. Now later on in this unit we'll have actually a more mathematical way to solve this and get an exact amount of time, which is when we could plug in a 0 for the output and make the entire quadratic equation equal to 0, and then we would solve the quadratic equation through one of the methods that we're going to teach you. However, since we're not to that point right now, we basically only have the graph to work with, and we really don't have a way of solving this 0 yet, but we do have a way of solving this maximum. We can get a sense of how long it's going to take until it gets to its maximum height by finding the vertex. And so what we're going to do, we're going to find the t for time, and we're going to use our a, b, and c values necessary to plug into this. And so we need negative 120 over 2 times a, which is negative 16. Which is going to give me roughly 3.75. And so what that means is that's my time at the height. Okay, so at the height of the maximum height of the ball, it took 3.75 seconds to get to that point. Now, what you're going to learn later in physics and kind of come to understand is that these quadratics are traveling at a consistent rate here of change, and gravity is having the same pulling effect on the ball as it goes up and as it goes down. And so based off the force at which the ball was hit, you can count on it being somewhat of a constant. Now your physics teachers will get into more detail about the velocities and the force and everything that's applied to the ball, but in essence, if I know that it took me roughly, let's say, 3.75 seconds to get to the top, we know that that's basically an axis of symmetry. So the same amount of time it took me to get from here to here, it should take me roughly the same amount of time to get over here. So if I double that, that 3.75 times 2 would be roughly 7.5 seconds. Now at this point, that's about the best that we can do, and notice that the problem says about how long. Later on, we will definitely be able to solve for this for a little bit more specific value for the exact time. But right now, 7.5 seconds is a good estimate. Now, second part of this problem says what's the maximum height the ball reaches. So we want the output part here to see what that vertex is, and so we're going to take that 3.75 for the vertex, and we're going to evaluate this problem at 3.75. And again, the better you get at using your calculator and punching all this in one entry line and coming up with an answer, the better. That's going to serve you well later on. So that's 229, and of course that's representing feet. So the height of the ball reaches 229 feet. Alright, well there's a good example of how we can use a lot of our graphing skills to answer word problems as well.